So we are ready to start with a second lecture of this morning. And our speaker is Shafi Goldwasser from Weizmann, MIT, and Berkeley. And she is also the director of the Simons Institute of Computing. She made fundamental contributions to cryptography, computational complexity, computational number theory. She received numerous prizes, and I'll only mention the 2012 Turing Award. And she will talk today, I'm tempted to say immunity and democracy, but actually the title is Algorithms and the Law. Shafi.
Okay, thank you. Thank you, Noga, and thanks everybody for coming. I know the title talks about the law, so I assume there are also people here who are not necessarily computer scientists, and I'll try to make the talk accessible to all of them. But I want to first of all say something to Christos. I agree with you on one thing, but I disagree with another thing. So I agree with you completely about the Berkeley Hills. That when you stand there and you see the view, you think to yourself, wow. I mean, and it's every day, except when it's foggy, which is like 3/4 of the time. But the other thing I disagree with you about the animals talking. And there is actually going to be a workshop at Simons. I disagree with many people. That's fine. That's better. But in any case, I think that there's actually evidence of the fact that they do communicate, and we go beyond dolphins and sperm whales. So that's a really great question. And in any case, there'll be a workshop on, it's a bunch of marine biologists and machine learning people trying to determine whether there is a language aspect to the communication. And also there's a woman who's going to, Professor Lilach Adani, who's going to speak on Wednesday, I think, about evolution, but she has some very interesting papers about plants, listening and talking. Now, whether it's language or not is a different question, also how we define language and what's the purpose of it, but I disagree. In any case. No, I mean, who knows? Okay, so this talk is about, so I've modified a little further than algorithms and the law. It's more about cryptography, or cryptographic type of research in the law. And I want to thank a lot of people who've helped me with this talk, because again, it's not my expertise. Kenneth Bamberger from the law school at Berkeley, Ran Canetti from BU, Aloni Cohen, who is now in BU, used to be my student, Frank Partnoy from Berkeley Law, Yonadav Shavit, my son, who's doing a grad student at Harvard, Mayank Varia from BU, Prasad, I can't pronounce the last name, and Daniel Weitzner from MIT. Okay, so first of all, what about my personal journey here into law and algorithms? It's really been because I moved from Boston to Berkeley, and I wanted to keep in touch with people in Boston, in particular after a year at Radcliffe, and we decided that we're going to teach a class that had sort of lawyers in it and computer scientists in it, and we're going to do it on video, so half the students were sitting in Berkeley, half the students were sitting in Boston. We were giving lectures across. So we had faculty who were both computer scientists and law people, and the orange people are the law people, and blue people are computer science. And we've ran it twice, once fall 2018, and the other one just finished, fall 2019. And in addition, there was a course that's being taught at MIT almost every year for a long time about privacy in the law, sort of privacy from the computer science perspective. And by Danny Weitzner, who is both in Georgetown Law School, and also he works at MIT, lectures at MIT. And all these students were either students of mine or my son, and they've taught me a lot. So the truth is that this is really because really my students have, never mind for those who don't know what that means, but essentially it means that my students have taught me everything here, and I'm presenting it. So what were the lessons learned from this journey into teaching this law class? So I guess the biggest lesson is probably something we could have guessed to begin with, but it became very, very apparent, is that there's a huge language barrier. And it's even bigger because we kind of we all speak English to some extent. And the thing is, we use the same words to mean something completely different. So when the lawyers or the judges talk about proof in court or evidence, it means something completely different than we talk about proof, and mostly in the sense that it's not defined. And there is some definitions, some guidelines, but it certainly doesn't have probability distribution, talking about high probability and low probability and what the space is. Similarly, when you talk about probabilities, that's another big one. When you talk beyond reasonable doubt, or the different parts of law require a different type of certainty. Again, when we talk about probabilities, we have to be very precise, and we have to, it's very clear what the probability means, what the probability space is. And there are many such, cases. And there's also a knowledge barrier. Like, we don't know enough what the spirit of the law, why a law was written a certain way, what is the intent. Often the intent is actually to be vague and to be able to interpret it, and they don't know what we can offer. I think it's a big one, that there is a lot of things that have been developed in computer science, besides running an algorithm that's over Google, and fundamental technologies that nobody, seems to me, outside of our field knows, but that could be actually interesting to use in the context of legal procedures. So I do think that the interdisciplinary effort is as necessary here because there's an opportunity. Okay, so that's kind of the big lesson. And I would say that a lot of people talk about law for governing algorithms, because we know now there's algorithms for setting bail and deciding whether you are allowed to get a mortgage, or policing. There's a lot of hype about that, and it's not just hype, it's for real. In California now they have this bail, no bail, it has to be decided. It's not cash bail anymore, but just whether you give somebody bail or not has to be decided by an algorithm. There's a lot of money out there for companies to implement such algorithm, a lot of money for companies to scrutinize those companies that implement the algorithm. It's all supposed to be black box. So there's a lot of discussion about the first, but I want to talk about the second, which is kind of the reverse direction. So not law for governing algorithms, but more algorithms, not really for governing, but maybe in some sense for governing and implementing law. And not just algorithms, but also maybe the emphasis even more is on formal definitions for law and regulations. Yeah. Yeah. Okay, so for governing algorithms. What I meant by, right. My course is called Law and Algorithms. I don't know what it's called for real, but what it should be called. Okay, I'm sorry then. I think law, it probably was. So I think the meaning, not that I think, the meaning that, my meaning when I wrote this sentence, law for governing algorithms, is now there are going to be these algorithms, and somebody has to say how they can be used, what's reasonable to use them for, what's not reasonable to use them for, within different settings, like courts or banks and so forth. That's what I meant. Right, so, what do I mean? We're gonna not, I will speak of specific algorithms, and then there will not be any question, what do I mean? Okay, because it's, of course, too wide a word to use. All right, so the outline of the talk will be sort of a taste of three directions that I think that we have something to say. One is really definitions, as I said. So we have a lot of experience, especially I think as a cryptographer. We've spent many, many years, 40 years or so, spending time on trying to formalize what an adversary is, trying to formalize what security means in many contexts, like encryption and digital signatures and protocols. And I think that this ability can translate also to this legal arena, and I'll show you an example. In particular, I'll give you sort of a crypto-style definition for something called the right to be forgotten, which is a part of a regulation called GDPR. So this is the European law for privacy, and there's some statements in English there of what they expect big companies to do, big data collectors, and part of them talk about this right to be forgotten. I'll explain more what that means. And then the second part of the talk, or the middle part of the talk, will be, so we'll move away from definitions, and I'll show you that even some existing cryptographic techniques, in my opinion, like multi-party computation and zero knowledge, which I really give just 1-minute definitions for people who haven't seen this before, or not from computer science, that they have, in my opinion, some potential. Of course, this would require codifying regulations in an algorithmic way, and it would require the agreement of legal scholars. This has value. But in my opinion, there is a potential there. And then finally, if we get to it, there's sort of a case in point. In other words, this has actually been built with this. There is a system that we built that is supposed to enforce accountability in surveillance. Okay, so it's a prototype. It's a conference paper that appeared in Usenet. So obviously, it's not a system, but it responded to something that was raised by a judge. And it was reviewed by him, and who knows, if these kind of things improved, I'm sure 10 times fold, could be used in practice. Okay, so there'll be sort of three parts. So first of all, about this right to be forgotten. So this is sort of the obligatory style on that slide, and that is that we know that there's a lot of data that's being collected, and this has enormous potential in many, many different subfields in health, in disease control, in finance, infrastructure, obviously vision, natural language understanding. Also these days people talk, especially in the context of people worried about social issues, policing, bail, credit rating. That we're going to use algorithms to replace decisions that were previously done by humans. And obviously these algorithms are going to be based on data from the past. And in addition to that, as I understand it from my colleagues who admit this freely, these algorithms do miraculous things, but nobody really can explain why. And some of these things like policing and bail and credit, require explainability, because somebody would like to know how to improve the situation. There's ability to receive a loan. I think even legally speaking, they're required to be able to improve the situation. Okay, so we know that data is important. We know that this means that those companies who hold data have now a lot of power. And if it doesn't worry people, then they're plain stupid, because, it's a complete change of reality, and we don't necessarily have to assume that that's going to result in better life than we have already. Not that it's that good, but in any case, it's not clear it's going to be better. But so there are these bodies of regulations. This GDPR is the thing I mentioned before. This is the European body of policy and regulation. It talks about what's sensitive information, what's identifying information. There's fines if you violate some of the things that they require, like not being able to single out users and so forth. And there's also California law. This is the California no, but the first C. Maybe it's something Protection Act. Yeah? Very good. California Consumer Privacy Act. And it's quite similar, but a little bit different here and there. And one of the questions, one of the sort of big, I think, reason why companies are worried about it is that they impose very large penalties. So it's not anymore a small penalty that doesn't concern anybody. It always reminds me about it in Israel on Shabbat, right? There's these stores that are open and they don't really care if they get fined because it's certainly worth to be open. Here they're going to fine in a serious fashion, so it actually is concerning. But one of the clear question here is, it's not even clear how does a company who is well-intended in the sense that doesn't want to be fined and wants to be diligent, how do they know they're even compliant? Because the law is very, very informal. There's a question of making an effort. Also, there's wording says you have to show that you've made an effort. What does it mean to make an effort? What does it mean to make an effort that results in compliance? That seems to right away require a definition. Okay, so the part of that. So this is not something that that we came up with, but it's the first time. I mean, this intent is the first time was by Kobe Nissim. Sorry, was really it's a joke for. So they brought up this question about formalizing the GDPR notion of singling out, and they have a beautiful paper that has a definition for what does it mean to single out. And really the idea there is that the intuitive first definition is that you cannot find a predicate on a public database that only is true for one line. But you can't satisfy that because a random predicate would satisfy, that could be true for it. So they have to kind of set the bar to be beyond that. So random predicate, obviously, you can't fight against it, but can you ensure that you can't do better than that? But what we are doing in this paper with Sanjam and Prashant, is talk about a different part of the law, not about singling out, but this right to be forgotten. So what do so let me tell you a little bit about this, as much as I know about it. So there was a case in Spain, I think 7, 8 years ago, where there's a Spanish citizen who sued Google Spain because he said that when they Google him, some information about him faulting on a loan 15 years before comes up, and he said that or his house was up for collection, and he said that he's already made good on this, and this information shouldn't come up because it hampers his business opportunities and so forth. There was a whole court case, and he won, actually. And when you use Google in Spain, you're not allowed to, because he asked it to be removed, you're not allowed, that information should not come up. Then there's a whole big question of whether this is also true of Google in the US, because he's a Spanish citizen, let's say in the US, should it come up or not? Never mind. The issue is, this is just an example that this has been tested in a sense, this request from Google to remove information about you, and it's been found in favor of the plaintiff. But obviously the regulation in GDPR is wider than that. It doesn't talk just about search in a Google engine, and it doesn't talk about something that happened 15 years in the past as something that should be removed. It's bigger and vaguer in the sense of what things are, what is your right to give consent to your information, how do you take away this consent, and what should these companies do in such a case. And essentially, there's a divide here. On one side, there's these data privacy laws, like these regulations, and they talk about right to be erasure or right to be forgotten, and they use words. We'll talk about this a little bit more. And the other side, there's sort of us who are supposed to, who know a lot about data privacy techniques. A lot of my slides are borrowed from, with permission, this is from Aloni. So there's a lot of data privacy techniques on encryption, multi-party computation, obfuscation, pseudonymization, lots of things. But the question is, how do these things actually talk to each other? I mean, do we have anything to, they have anything in common? Can we use them? In a minute, it will become, I think, clear why this is relevant actually to this forgotten business. For example, if something is encrypted in some, intuitively, in some sense, you have, and there's no key, you can think of that as erasure. Yeah. So the question is whether these techniques of ours satisfy the law enough. Okay. Of course, how can you answer that if you don't have a definition of the law? So the first step here would be to, this is the test case, sorry, that I mentioned before. It's coming a little later about EU court backs right to be forgotten. Google must amend results on request. So you. I just here wanted to mention before I go to how we define this is to say that the Google search was not the only example. Another example, if you think about it, where you want to be forgotten is, let's say, life insurance. You want to get life insurance. Maybe you were extremely ill 20 years ago, but it's all been fixed. You're not going to get life insurance if they can find out this detail. And maybe even when it says that you're not supposed to admit it on a form because there is some regulation that says that you're not bound to report it. Another idea, another place which is kind of obvious is if you committed a crime, let's say in the past, and they can find out that you committed a crime. Or if you are a minor and you committed a crime. There are many of these situations that you can imagine that things that have happened in the past are not necessarily, it's not necessarily fair in some sense that people will know it, but it will impact your life. Okay, so back to how do we define these things and how do we implement them? So this is the suggestion that you first of all go to the text of the policy of GDPR or CCPA, you extract the relevant text, you try to define it mathematically, you can analyze this mathematical definition, think about attacks that as computer scientists we would do, think about methods we have, do they satisfy our definition, and of course then you have solicit legal opinion, and this would be iterative. So this is kind of obvious, but it's still a recipe. In the particular case of right to be forgotten, for example, here's a few pieces of text that appear that are relevant to this law. So there's something called, in Article 6, it lists conditions when an entity may lawfully process your data. So not just store it, but actually process it. And the data subject is given consent to the processing of his or her personal data for one or more specific purposes. Then they say, in Article 7, that he has the right to withdraw his or her consent at any time. They don't say consent for what, but I assume it's consent for the first, where you've given your permission to process. And furthermore, you have the right this is another place where he talks about the right for the erasure of personal data concerning him or her without undue delay, and the controller shall have the obligation to erase personal data without undue delay. And then there's another number of conditions. It leaves vague the fact of whether you also have to erase the results of processing the information. So if you're given consent, they process the information, now there's some outputs. Do they also have to erase that because it wants you asked to, your information to be erased? So all of this is vague, and it brings room to a lot of interesting questions. To what extent this processing, the results of this processing should be erased. What we did is we have a definition here for what it means to delete data. And even this definition of just deleting the data has a lot more kind of subtleties than meets the eye, because data leaves a lot of traces. So that we know that. It's not just that it's stored in one place, it's used in many places, it's linked in many ways. And in order to kind of moderate your expectations, this first definition is going to be very general and simple, and it's also going to assume that the data collector is honest. He wants to be compliant. By compliant, I said complaint. He also wants to complain. Is that the same? Compliant? Oh. Okay, so no, he should not complain. We should complain. In any case, the data provider he wants to be compliant, he wants to be diligent, he doesn't know how to do it. Okay, but the definition at least tells him this is what you should satisfy, and then it's a burden on the technicians to offer methods to satisfy. Okay, and here's an example of a definition. Again, it's a definition one can scrutinize afterwards. I can myself scrutinize it, but it's a first definition. It's a strong one. So and this also gives you a taste of how crypto definitions look like. So here we have sort of the real world. So what's the real world? The reason I say the real world is not because I really mean this is the real world, but I'm going to contrast the real world with something I call the ideal world. In the real world, we have a data collector. So this is one of this company. It has some memory. There's a user. This is the one who gives, let's say, data, pi1, pi2, and later will ask some data to be, already up to here. So this user Y, he will give data, and then he is allowed to ask the deletion of data, multiple deletions, and also there's an environment which the data collector interacts with. So there's sort of three entities here. There could be more, there could be multiple users and multiple data collectors, but here there's one data collector, one environment, one user, and we want to compare this real world to some ideal world where there's still these three parties. But what happened here, and they have memory, they've interacted with each other, but in this ideal world, there was never any data stored. So there's the situation I stored data and then I deleted, versus the situation I never did anything, and I want to say that you can't distinguish those two. So it leaves no trace. This is a very clean definition. It can be complicated to extend it to what you would reasonably really want. For example, outputting, processing of data to the environment. Because the first question you would ask, and Adi I see is on the edge of his seat, is, or maybe you have other questions, is that how could you actually do anything with this? I mean, that's why I said that the environment is honest. And an environment? No. It's unachievable if I told the environment your information. That's right. That's the simple question. No, it's not sophisticated. Then you tell Google things about Shafi, and then I say I want you to delete it, but the things have already been given. Clearly, again, it's not that it's unachievable. What it means is you shouldn't say things about Shafi, and then you say, that's ridiculous, okay? All right, so we simulated everything. But the point is that this tells you that there is some burden on the data collector in what they're doing. So in other words, okay. So that is exactly what I said, but I didn't use the word download, but Google gave me some of it, yes. I didn't say that this is a definition that could be implemented tomorrow, but I do say that Google may be able to maybe keep information about who asked information that they responded about you. You would say that's unreasonable, but all I'm saying is, okay, in that case, you could see an extension where when Google gets a request that, from me to delete all my information, it gives me a compiled list saying these are the people who I gave information about you. Again, all this is the most strict definition possible and would only apply to some subset of tasks. But it's not an impossibility to think of an extension of this where you know who's gotten your information. We have gotten used to this world where we can find information about anybody, anytime, in huge quantities. And it's not clear that that is consistent with what GDPR wants. Certainly not consistent with this strong version of the definition. But it doesn't mean, yeah. Authentication is very important in order to achieve these things. So you're right. It's very important that the person who's asking the deletion can be authenticated as the user who provided that information to begin with. Let's take it offline. Is that what you're asking?
Google will remember that this guy asked to delete the query.
So these are two ex-students. These not. But why don't we discuss? So there are there's some obvious problems with this, then there's obvious fixes, and then there's probably non-obvious problems with non-obvious fixes. But all I'm saying is that clearly the data collector can do more than they're doing now in order to be compliant with data deletion, okay? And that is, in some sense, to give data in a different way or not to give it, okay? Because they want to be data compliant, and then they could say that could harm their services so much that the whole thing is not they don't want to do it anymore. So in any case, back just to the definition, there is sort of two places here. There's the view of the environment in the real world. There's the memory, the state that the data collector has. And then the same thing can be defined in the ideal world, sort of the view and the state. And the type of definition that we usually do in cryptography is we would say that X, this data collector, is deletion compliant if for all these environments and requesters, if you look at this state and view, it's indistinguishable in the real world and in the ideal world. This would be sort of how a cryptographer would come up with this, the first definition. And then you would say, this cannot be achieved. So notice, for example, communication here from the environment to the user is one direction. The user could also give it to the environment by himself. People know that I went to a certain high school in Israel. It's not something that they had to get from Google. So now Google is also responsible for the fact that somebody can get it. This definition, that's a more subtle problem. In this definition, the way this is eliminated, this is a one-way communication between the environment to the user. The user doesn't give things to the environment. It's actually good that you have objections because you realize that this is non-trivial. But that doesn't mean that it shouldn't be done. Okay? That's, I think, an important thing to realize. Okay, so that's a definition. Yeah. If in this world where you never got the data, the memory should be indistinguishable. So that's the state. That's part of the state. Yeah, absolutely. So actually, doesn't worry me. So if you could put encrypted in such a way that there's random encryption there, that's fine. Yeah. That part actually doesn't worry me. Yeah. Relaxed version of it? That's a legal question of whether they're going to agree that this requires compliance. I would assume that this is much more than what they intended. But of course, so that's why this work is in some sense in the air unless people who made the regulation would kind of swear by it. I just want to say that, the immediate reaction is, it's too much. But second reaction is that we actually have a bunch of methods already to achieve a lot more than what we do. So for example, if we just talk about not a Google, but a data service that stores your data. Stores your data for you, and then you're supposed to delete it. I don't know, it's Dropbox or something like that. Oh, right, Google Docs, yeah. Okay, so one of the lessons from this definition is that the way that they store data can be stored in a variety of ways. So let's say we take a simple data structure like a search tree where you store data, which is And we've had, a data structure usually has a legitimate interface. You know, there's like, you can insert, you can delete, you can do a bunch of things, but they also have a memory representation. And the question is, what is the memory representation to be used? So actually from cryptography years ago, there's a paper by Daniele Miciancio in 97, and then an extension of it, not extension, but the same notion to another data structure by Naor and Tig, where the idea is to take an existing data structure and make it into a history oblivious data structure. So a data structure that has the same operations, but instead of doing the operations deterministic, you have a randomized version of the data structure, so that when you insert, delete, and so forth, you actually you have a distribution over the resulting data structures. And the property is that we say it's history oblivious if any two sequence of operations that yield the same content induce the same probability distribution on the output. So in other words, whether I've inserted something, then I deleted it, or I never inserted it, okay, the distribution on the data structure is the same. So that, for example, is, if you could do this for very complicated data structures, I assume that Facebook doesn't use some simple search trees, there's a social network and implement, but somebody can pay mind to it, that if you wanted to extract part of it out of it, the distribution of the internal data structures would remain the same. I think it's very, very interesting. This was designed for other purposes, but I think it has relevance in this context. So in particular, we can show that it's history oblivious data structures plus authentication to address some of the questions that I think Zvika was referring to can achieve deletion compliance when you're only doing data storage. What's another setting? So say that what your database is a facility that has data that researchers can approach, the usual data differential privacy setting that researchers can approach and ask for data summaries. Right? Differential privacy actually by definition says that the outputs are going to be not really depend on a single entry, okay? Limits the amount of dependence on a single entry, which essentially means that if the collector, in addition, because it stands to reason, not only they're supposed to delete your data, maybe they're also supposed to delete summaries of your data. Here, at least, if they've used a differentially private mechanism, the summaries of the data there's no need to delete them. They, by themselves, already satisfy this deletion compliance property. What's another example? So let's think about machine learning. So apparently, there's a bunch of papers recently that talk about machine learning models where you can delete training data. So say that you've trained a model on data, and now you want to delete part of the data, either if somebody asks you to delete it, you've discovered that data was false, or something like that. The question, of course, you can always retrain on the new data set, but the question is, can you do it more efficiently? Can you actually use the existing one and just update it? And they have some papers suggesting how to do it. That, again, is a way to, if you do that, plus the data oblivious for the internal data structure, points to a way, in fact, there's a theorem there, that a way to represent machine learning models in a way that's deletion compliant. Again, there's a question here, what about the output of this? I mean, you've used it in some sense. Internally use it as one thing, giving it to the environment as another thing. Okay, so all I'm saying is there are ways, at least to the things that we often talk about, data summaries, machine learning, storage, or information about you, that can be done in a different way that might be even compliant with such a strict definition. Okay. Third. There are lots of directions for the future on this part, to relax it, to make it composable. It's a big question whether it's composable across different data collector systems, and even to begin with, which deletion requests should be honored, even according to the spirit of GDPR, and maybe inconsistent with something that can be achieved. GDPR is very vague about that. What should be honored, what shouldn't be honored, what it means. Okay.
Internet archive. Sometimes you are deleting the data and accessible.
That's a good question. What do you think? Should it be? Should it be disallowed? No, I'm asking, should it be disallowed? The whole thing about this, it's a discussion in the sense that the GDPR came up. Now we're trying to codify it. It's a back and forth. It's an interesting question. Should it be disallowed if it was 20 years ago? There's some time limit on it. It should be subject to this law, and this right to right. And this, and the point is that this is an environment. Well, you know, I don't want to get into these. They're not details; they're reality. But interesting question. Okay, so the second thing I want to talk about, which maybe is more sort of something tedious about this first part, but even though it's relevant to the reality, is that I think that there's a potential of using cryptographic protocols for better legal procedures. Now this, I'm putting myself on the line there, but at this point, so, okay, so first of all, I'm talking about secure multi-party computation, okay? So, people here, all but I don't know how many, know about it. So there's a bunch of computers, they're connected through communication lines, they each have separate data, and they distrust each other, they want to run arbitrary program on the aggregate data without revealing the individual data to each other. This can be done under a variety of conditions, either physical channels, some cryptographic assumptions. Okay, so we know this from the 80s, and there's a bunch of conditions, not so important. There's even, apparently, multi-party computation has grabbed the attention of people in Senate, in the US Senate. There's a bill that describes it as following. The term secure multi-party computation means a computerized system that enables different participating entities in possession of private sets of data to link and aggregate their data sets for the exclusive purpose of performing a finite number of pre-approved computations without transferring or revealing any private data. So this is in English, and this is very understandable. There's a technical definition that captures it. You know, this is the usual definition. Let's say a bunch of hospitals, pharma companies, they want to share data because they can extract more knowledge out of it. And they shouldn't give it to each other because of HIPAA, other regulations, and still they could use multi-party computation in order to access the data or to process the data. Okay, so here's, so we know all this. What does this have to do with law? Where is an application that has sort of a legal flavor to it? Okay, so here's a lot of words, so let me try to say them. So there's this very nice paper by Mulligan and Bamberger, both from the law school at Berkeley, where they point out that something that people, I think, some people maybe have observed elsewhere, it's within the context of a very large paper, that enforcing privacy by design. So for example, there are some things called protected attributes, like race, and things of this sort, and you're supposed by law to erase it in a lot of applications because it's not supposed, decisions are not supposed to depend, let's say if you get a loan or not, on whether you are white or black or Asian and so forth. And they point out that that's very nice, but in some sense, instead of doing good, it does harm because it makes it impossible to tell later whether there was really unequal treatment, which may have been applied because of things like zip code, things which are not directly race, but that are strongly correlated with race. So saying in general, this on one hand, you're trying to do good, and this is called this disparate treatment. You're not supposed to treat people differently depending on certain protected attributes. But the result of it may ironically result in what is called disparate impact, which you're not supposed to have. And that is, things should be fair according to race and gender and all that. But on one hand, you're not allowed to look at it. On the other hand, you're allowed to have a result which supposedly, by not looking at it, is going to be fair. That's not the way it works, okay? So here's a proposal. How about running multi-party computation, the crypto kind, on collective data, let's say my data with my gender and my race and so forth, and all my attributes, to gather information about bias and fairness of the machine learning algorithm. So in other words, there's a machine learning algorithm, it's getting inputs, and it's processing it, and in order then at the end it decides whether to give me a loan, okay? If you could hide from it what the data is that they're working on, okay, but within the algorithm correct the fact that it would be fair, there would, in other words, it would be the right proportion of race and gender and whatever else it is that you want, okay, then in a sense, you've relieved the tension here, in my opinion, between disparate treatment, which is looking at that race, gender, and so forth bit, and the outcome, which is the disparate outcome. This is a question to the legal scholars. Is that true? Is that if a multi-party computation afterward it did look at the race bit, it did look at the gender bit, it just didn't really look at it, but it made the outcome depend on it. Would this mean that this does not constitute disparate treatment? Now, there's probably legal scholars here, and my guess is you would argue one way or another way. But I see a potential here to actually circumvent a law that was intended for good intentions, but in my opinion, achieved. Did I do something to the speaker? No. Okay. Here's another example. This has actually been done in some sense. There's this wage, maybe people know about this. In BU, they did this project where they wanted to find out whether the average wage whether the wage to women and men in different companies is the same. But nobody knows what the benchmarks are, or is it the same across companies. So they reached out to a whole bunch of companies in Boston, and they were willing to give their data through a multi-party computation. So they didn't want to give their data to anybody. Their lawyers approved this method, and they computed what the sort of average salaries are, and they had a benchmark to be able to tell whether in their case they are above or below that benchmark. So again, it was a way to look at the data and not really look at it in order to provide some legal advice about salaries. Okay, so this is this one. Now, what about zero knowledge? I said that that's also something that could be useful. We know proofs. Again, this is for people. I'm thinking of a proof as an interaction between a prover and someone who's verifying a proof. The usual example is there's a product of two primes, n equal to pq. And how does the verifier, who doesn't know how to factor integers, know that it's two primes? Let's say that she's very smart. She finds the two primes. Maybe she knew it to begin with. She sends him the two primes. He multiplies. But if we use this, hear me? Sometimes? Now? So let's say this is Adi's already 1986 is that we can think of Alice as someone who knows some composite numbers, say, and she proves that she knows it to Bob. The thing is that one way for her to prove it is just to give those two primes, but let's say Bob is target, he leaks the passwords, then he comes out with this announcement saying, we take this matter very seriously and we are working with law enforcement to bring these responsible to justice. So the question is, can she prove to Bob that she knows these prime factors without giving them away to Bob? And that's what zero knowledge is about. So we have a way to do that. So we have a way to prove that Alice can prove that she knows that there is a prime P and a prime Q such that she knows them, and therefore she is Alice, and she can buy a target freely. Okay, so these are slides that really are just not new to anybody in crypto, so I'm going to skip them. A lot of uses have been made out of these ability to prove something without giving away the classical proof. So the zero-knowledge proofs, we prove nothing except the validity. Passwords was one. People have talked, Boz is here, which you can tell the story about nuclear disarmament. It's kind of a strange story about a cafeteria in Princeton. Is that right? Some physicists heard about zero-knowledge proofs, and then they thought it would be useful for nuclear disarmament. Then there's DNA innocence proving, which Moni, I don't know if he's here, Moni Naor and some students also talked about. But how do you check that? How do you prove to someone that you were not on the crime scene without giving them your DNA? So keeping your DNA private and yet proving that it's not identical according to the right definition of identical to DNA on the crime scene. And going down to earth, we certainly know about validating transactions and blockchain, preserving privacy anonymity. There's the Zcash company and some other companies in Kedet and so forth. What about law? So if we go a little bit further, you can talk about verifying tax returns by the public, verifying that they're compliant with the rules, without actually knowing who paid what taxes to whom. Or you could verify whether documents are privileged attorney-client, documents. This is something that apparently happens time and again. And the way that you determine if something is privileged or not is that you go and you look at the document. So it seems a little problematic to me. But of course, it's the only way to do it. Or is it? It isn't. We know it isn't. If you could codify how you look how you decide whether something is privileged or not, then you could also do it in a zero-knowledge way. So it would be really the intent, which is you're not supposed to look at the document in order to determine things that are based on that document. So I think the general question is, again, how would law treat this idea that you could decouple verifying claims, verifying legal claims, without knowing the facts? I think it took a long time also in crypto to accept it, or in complexity theory, but we kind of accepted it. But would that be acceptable to as a legal, is that enough of a, satisfies whatever desire you have as a lawyer or a scholar, that you believe that facts, the verity of facts is more important than the facts themselves. And of course, when we do this, there's a probability of error, And that's, again, something that's extremely small. We are feeling comfortable with it because we know numerically what extremely small is. But would that be comfortable by someone who, in a legal setting? Maybe the most interesting application is this idea that you can have new ways to do mergers and acquisitions. So this is the whole thing about how companies decide to merge, decide to acquire other companies. And a big part of that is due diligence. So a big part of that is to check what is the state of this other company. Who are the customers? What's the internal IP and so forth. And apparently a lot of these deals do not happen because people are afraid that all is happening here is a fishing expedition. And there's a whole economic theory called the theory of the firm, which says that this desire of secrecy is what governs how companies in fact merge and acquire each other and why the market goes one way or another. So imagine a situation where you could due diligence in a way that keeps private information private. And this way you could mitigate those risks of disclosing information. I know there's NDAs, but apparently even those people don't respect, and then suing someone for not respecting NDA has a cost in itself. I think that's a very interesting question. If you could do it, what would it mean to this whole economic theory of the firm? So again, I'm allowing myself, given to my age, to put this out there, but I don't think it's without basis. Right. Right. Oh, sure. Proving the fact that your idea is worthwhile or something. Absolutely. So I think all these things I think it has potential. The whole question, of course, is if you can codify these things that you do now by looking at the document into something that a computer does. As soon as you do that, then the barrier really is just implementing the zero knowledge, but we don't have any I think the fundamental barrier is how do you write this down as an algorithm. Okay, so I don't know what time it is. 10 minutes, okay. So the last thing that I want to talk about is this case in point. And that is sort of something that we've done. So as you know, there is this Foreign Intelligence Security Act, which allows the US government to do surveillance on foreign nationals. And apparently there's lots of them issued every year. But there's also the federal laws, which means that you can also inside the US, do surveillance on US citizens, or what you need to do is go to a judge and get a warrant. If you have to and then you take the warrant. I guess there's a law enforcement agency, FBI, goes to the judge, asks for the warrant, gives it the warrant, goes to the company, asks for the data. The company may challenge this with the judge, but let's say at the end it has to, so it gives your emails or whatever data has been requested. And the secrecy, of course, of these investigations is key. Otherwise, there's no point in it. So you're asking surveillance, and then everybody knows about it, then I guess you don't talk. Although, everybody with all those machines around their house, they talk freely. So it's unclear that even if you know that you're being surveilled, that you change anything. But, so there are these laws. They're sealing a case, preventing court records from becoming accessible to the general public. That's what sealing case means. There's something called a gag order, that you can't even say that an order exists, mentioning it to others. So there's a body of law that governs the fact that you're not supposed to disclose that an investigation is going on. And what this judge, Judge Smith from Texas, he wrote a bunch of papers because he noticed that it turns out there's also a law that says that after the investigation is over, 30 days or something, you are supposed to lift the gag order, lift the secrecy order, so that the public has available knows that there was an order. It can sort of assess the magnitude of how much surveillance is being done. But it turns out that it's very rare that a judge lifts it. So there's a lot of these cases sitting under gag order, because there has to be an act to lift it. It doesn't happen automatically. And it shouldn't happen automatically. You don't want by mistake to kind of reveal everything. So he has these papers, gagged, sealed, and delivered, reforming. And his solution was, so first of all, why is it a problem? So he says it's a problem because the law is that they're supposed to open it. But not only because they don't obey the law, but they're claiming that, he's saying that the only way to change law in the US is to have sort of appellate guidance and to kind of know what's going on, and then you could sort of challenge it. And there is no way to do that because nobody knows about it. The public doesn't know about it. The only affected party doesn't know about it. And that's the problem with not opening it up to scrutiny. And then his suggestion was, I just want to know that it's not completely true what I just said. Google, Facebook, and Microsoft, and so forth, they do publish reports similar to the report that you mentioned about, financial, reports that talk about how much surveillance they were, the requests they got and what they said. But they don't, but there's no way to know whether this is the right numbers. There's no way to know what type of, why they were asked, okay, for surveillance, whether it did anybody any good, and what type of surveillance. Was it invasive? Was it partial? And basically, does? So also in Israel, okay, and apparently this is sort of an overview of the cases and how it's been going up in terms of how much surveillance has been requested on your digital information. So his proposal, the judge, was to have a cover page. So each one of these cases would have a cover page, and the cover page will have some metadata about a sealed case, and that should always be made public. As you're giving the warrant, there's a publication that says there is a case that's going on, and some information on that cover page. There's a clear tension here is what do you put on the cover page? What do you prove? You just do an X? I mean, what information do you put there? And there's a clear tension here between privacy and accountability. That's obvious. So it's kind of like obvious that what we know how to do is relevant in order to do accountability. So what we did is we sort of came up with a system which offers sort of accountability and privacy at the same time. So, and it uses the kitchen sink, knowledge and multi-party computation, and even public ledgers, because this is a notion of time that it has to expire, and what happened before what. And essentially, public now can check that each participant in this triangle performed their job properly and lawfully, and also part of the multi-party computation aspect of this is to do aggregate statistics over all the court orders. So here's kind of what the system looks like. Sorry, that's the threat model, and that is that there are these judges, many of them, and they're giving warrants as, like hotcakes, סופגניות, what? And the thing is that, multi-party computation is very nice as a concept, but it does cost. So if all these judges were doing multi-party computation together, not so good. Anyway, the judicial system is overworked. But there is, apparently, in the judicial system in the US, there is a hierarchical, so there are these district courts, there's 12 of them, and the idea was that there's something called hierarchical multi-party computation, where the people in the bottom, they're sort of splitting their decisions, they're giving it to these middle courts, and they will do a multi-party computation where they aggregate the information, and they talk about how many of the requests were, how many of them were for one purpose, for another purpose, maybe just threshold. There was a bigger, was it bigger than 1,000, what state were they in, and so forth. So, of course, there's a question here, definitions, like I said before. What's the threat model, really? I mean, the judges, I guess, are honest but forgetful. The law enforcement might be malicious. The companies might be malicious. The public might be malicious. And you want this protocol to work within this threat model. But in some sense, this is engineering. I mean, once you have the intent and we have all the tools, you have to put it together correctly and prove it to achieve this accountability. So I think I've, some data. Obviously, I didn't make these graphs, my students. So this is Jonathan Franco, Sanu Park, Daniel Schall, and then it was me and Danny Weitzner on the sort of a professor side. We did show it to this Judge Smith, and he was very happy. He said, my hope is the court administrators will embrace the possibility of enhancing public oversight, that lessons learned here will smooth the way toward greater accountability. Now, he is very, I think, I don't know the word. He's a very enlightened judge. Just being a judge is not equivalent. So apparently he's shown it to a committee of people who were responsible for this, and they rejected it out immediately because they said if it's not broken, why fix it? And it's too much of a headache, and there'll be software bugs. And I agree about the third. There'll be software bugs. Software bugs. So software bugs is always a complaint which has grave truth to it.
So they are enlightened also.
Yeah. Yeah. Right. But I think this is also a conservative bunch. And rightfully so. So it moves slowly. So just the fact that they rejected it immediately the first time doesn't mean that there isn't something here that can be accepted. Okay, so there's also, I just want to say a word that there's this first thing I talked about, the foreign intelligence. And there's something called a body of secret laws. It's not exactly a law, it's regulation, where you don't even know what the reason is, what the law is according to which the judge or this court authorizes surveillance. Even here we know in principle what to do with zero knowledge. So there's a secret law and there's a secret order, and you have to show that they're consistent with each other. So I'm saying even when the process itself, the rules themselves are not necessarily public, you can imagine that the technology that we have in principle, mathematically speaking, can handle it. Just want to end, there are lots of other scenarios, you know, there's some examples out here about violation of contract with secret laws. You want to check that whether the contract was honored or violated, even without finding out what the secret clauses are. Litigation, which is could be very harmful to the person who gets charged. And I want to say that and this is a shout out to a workshop that we're going to have at Simon's on algorithms in the law, organized by a bunch of Michals and Inbal, and Elkins Cohen, Feldman, and Talgam Cohen, and that it's not just about privacy. That's my expertise, and that's why this whole lecture is about privacy or cryptography. But there are other, you know, societal values besides privacy, fairness, freedom of speech. And on one hand, there is sort of a mathematical formulation that we have come up with, maybe in cryptography. Maybe we should modify it. And then there's the legal doctrine that governs it, like the right to privacy, anti-discrimination, duty of care, copyright. And there's an interesting question in all of these things. What is the algorithmic task in order to satisfy the legal doctrine? How do you mathematically formulate it, which is consistent with the legal doctrine? I think it's fascinating. Thank you.